By the end of this session, you should have a better understanding of what sound is and how it is produced. Imagine a membrane such as the surface of water. If a drop falls into it, a ripple is sent across the surface. Sound waves operate in the same way, but are caused by changes in air pressure. A single wave has two parts, compression and rarefaction. This happens when a vibration disturbs the air, causing an upward motion, which is compression, followed by a downward motion, which is rarefaction. One wave consists of both upward and downward motions. Compression is also called the crest and rarefaction the trough. The height of each crest and trough determines the amplitude, which defines how loud it sounds. This is measured in decibels. When two waves are combined with the same amplitude and frequency, the amplitude is doubled. In other words, it's twice the volume. If two waves with the same amplitude and frequency, but opposite crests and troughs are combined, they cancel each other out. Sound travels at approximately 750 miles per hour, or 1200 kilometers per hour, depending on the temperature and humidity of the air, which corresponds to 330 meters per second. Frequency consists of the number of complete crests and troughs occurring in 1 second. This is measured in hertz, so 20 cycles per second equals 20 hertz. The frequencies the human ear is sensitive to range between 20 hertz and 20 kilohertz, or 20,000 cycles per second. This changes as the person grows older, with the range growing shorter. The wavelength of a sound producing 20 cycles per second is 17 meters, whereas the wavelength of a sound at 20,000 cycles per second is 1.7 centimeters. Acoustics in sound recording is defined as the way an environment affects the quality of sound. Some buildings help to amplify sound, such as cathedrals and theatres. Other places, such as an office, can dampen the volume of audio because the walls can absorb sound waves. Reverberation is caused when a sound wave bounces off a surface and travels in another direction. Certain objects will absorb the energy from the sound wave, such as curtains and clothing. In this session we have looked at what sound is and how it is produced. Earlier in this tutorial I played a range of tones from 60 Hz to 14 kHz. Download a copy of Audacity, an open source audio editing package, and install it onto your computer. Click on the Generate menu, then Tone. A new track will appear and a small window called Tone Generator. The default frequency is 440 Hz. Click OK, then play the track to listen to the tone. Once you've done this, do the same exercise again, changing the 440 Hz to something in the range of 20 Hz to 20 kHz, and then see where your hearing range is.